Hey, how's it going, everybody? So, way back in the day, I ran across the legend Johnny Lee here with his head tracking demo. And man, I always thought this was just the coolest effect. It's like basically turning just a regular old flat TV into like almost this holographic display sort of thing. I always thought it was super cool. So, I'm going to try and recreate that over here in Blender. And you can see what I've got here is if I move the camera around, you can see from the rendered point of view that the walls always stay lined up. Like the corners are always right. And the big important thing with that is we got to figure out this camera frustum so that the lines from the camera they come out and they hit these corners. I've scaled up the camera here just to make it easier to see it. But the big thing is we just got to hit those corners wherever the camera is. So yeah, so we're let's go ahead and just try to recreate that from scratch. So just gonna delete that camera and make a new one. And here we go. So there are a couple important things for this setup to work right. We're making a few assumptions here. So one of them here is this box. I'm calling this our quote unquote screen. The big important thing here is that it's the same proportion of the screen. Aspect ratio. For this setup, I'm assuming that the front of it lies at the origin, so it's like 0, 0, 0 right here. And then one other thing about this is just that the scale and the dimensions match. You know what I mean? So like this is 26 point, practically 6, and then this is 26.6, right? So that's important that those match. The other thing here is that the camera has got to be lined up along the same axis as it, along this y-axis, right? So I'm just going to set that to 90, 0, 0. And you can see now the camera is just looking down the line here, right? So we're going to switch into our view, and we can see we're looking at our box here, but it's not right. We can see that it's not hitting the corners, and if we move it over, it obviously isn't going to work right. Okay, so there's a couple things that we can play around with here. Over in the camera tab here, we can play with the focal length to try to get this thing sized right. Another thing we can do is we can play with this sensor size, which these are very related to each other. They're we'll talk about more later. It'll be handy. The other thing is like if the camera is off here, you can see we still have our edges are parallel here, but they're not in the right position. So we can use our lens shift to shift things over, right? So that's what we're going to be doing. So the first thing we want to do is get where the camera is lined up on the 0, 0, 0 axis, like it's lined up on the screen axis. So we just got to make sure, we got to find the right value for our focal length and our sensor size to make this thing actually line up with the edges of our box. And the way I found to do that is if we look at the size of this thing, if we just take the dimensions of the x-axis and put that into the sensor size, and then, got to put in just the number. So 26 or zero point 0.6 millimeters. But okay, so we do that, and then the other thing is this focal length here. Then that just turns into the the Y position of the camera, which is this, right? So just take the number there. I'm gonna put it in here, but I'm gonna have it be a positive number because negative focal length doesn't make much sense. But you can see from there now the box actually lines up exactly. So it's no good if we move or anything, but you can see it actually lines up just right. So to fix that whole thing where if we move it changes, we're going to use a driver. So the first thing I'm going to do here is for the camera sensor size, I'm going to right click the size field and I'm going to add a driver. And then I'm going to right click and say open driver editor. And this gives us a little window. If you're not familiar with drivers, they're super nifty. But the big thing here is that it lets us update the value that we're driving based on other variables. So for our sensor width, what we said is we wanted it to be the same thing as the dimension of our wall here. So I'm going to say what object I want to drive this. I'm going to scroll down my list. I'm going to find my wall. That's this box thing here, right? And then we can pick out different things. So I'm going to pick the X scale, and the fact that that's scale, because you see there's not a dimension in there. We just have scale, and that's why I was saying that those values have to match. So once we've got that, that's going to say it's going to take this value that we select here, and it's going to put it in this variable, this thing called var, var. So up here in expression, I'm just going to change this thing so it's literally just the variable. So it's just going to take this value and put it here, right? So that means if I change the scale of this, you can see in our thing here, it's still staying at the right size. So that's cool. That's what we want. That we've got it so that it's actually driving it. All right. So I'm gonna go back to the camera. So next thing we want to do is, so if we move the camera's position in and out, I want that to update. And we saw that was changing the focal length, right? So I'm going to go ahead and right click and add a driver. And if in this driver editor you can see the camera, if we just expand that, we can see the things that we're working with. So I'm going to make sure that I've clicked on focal length. And the focal length, this time I want to be driven from the camera's position. Specifically, its Y position, the Y location. But we again have this thing where it tacks in the value. So I'm going to delete that. But that's still not quite right because our camera is moving its negative location. You can see the driver value, it's negative 33. So I'm just going to put a negative sign here. And then that means, our new value is 33, right? So this is cool. So now we can move the camera in and out and we stay locked. And if our thing changes sizes, we stay locked. So that's cool. So our next problem here is if we move off to one side, now we're not right anymore. So we got to figure out how to set these shift X and Y so that those match. So we're going to add a driver for the X here. I'm going to click on that in here, so I'm working on the shift X. So for this guy, we know that we need the camera's X position, right? So I'm just going to go ahead and get that. So we got our X location, and I'm going to change this variable from var to X position. And the reason we need this that I'm changing is because we actually need two variables this time. Not only do we need the X position, but we also need to know the width of of our wall here, the screen, because that's the units that the shifting works in. So for that, I'm going to turn this one to a transform channel. These are different things that you can use to drive, but we're going to use a transform channel. We're going to call this one width. We're going to pick the wall, and we're going to pick the wall's X scale. So now we've got two variables. We've got the X position of the camera and the width of the wall. So now we can write an expression that is negative X position divided by width. And what that is we want to take the X position, but when it comes to the camera, if we're shifting over to the right, we want to kind of shift the lens to the left, and vice versa. And then we're dividing by width just to get into the units that were being used here, because that's what the lens shift uses, right? All right, so that gets us our X. Obviously, Y is still not working, so we're just going to do the exact same there. Right click, say add driver. Again, we're going to need two variables, so I'm going to say the Z position, so up and down. We're going to get that from the camera. We're going to say Z location. Then we're going to add another input variable and again change it to a transform channel. We're going to call this one width and pick it up from the wall and say X scale. So again, we've got the Z position, so it's up and down. And then it's the width of the wall. So initially you might think that, well, this one, the X was using the X position and the width of the wall, maybe this one should be using the height of the wall, but it's not. The camera sensor size is based off the width here, so we're going to use the width again. So let's say negative Z position divided by width. And there we go. So now we can move the camera all around. We can move it in and out. Let's see, in and out. And if we want to, we can change the size of that. So that's the trick. Basically, once you get right down to it, what we're ending up doing is we're adding drivers to these 4 fields: the focal length, the lens shift on the X and Y, and the size. And there you go. That's the thing.